Welcome everyone to this seventh edition of the Azure DataFest. Can we go to the next slides, please? So we are seventh DataFest, and here is the planning. Wait. Can we go back to the schedule? Yes. Give some time for everyone to join. It's still a bit ahead of time. All right. So again, a warm welcome to everyone on this seven sessions of the Azure DataFest edition 2021. Today we'll deep dive in massive networking. Here we are talking about tens of gigabytes per second to host your data workload. Before that, I'd like to introduce a few housekeeping rules. If we can go to the next slides. To remind you a few housekeeping rules which are here for every sessions. Please use, I encourage you to use the Q&A sections to post your questions. You can do so anonymously if you want to. Questions will be answered in the chat as well at the end of the sessions. We have a 10-minute break for the Q&A. Right. Next slides. At Microsoft, we see sustainability and humanity's response to climate change as one of the greatest challenges of our lifetime. We believe it's not too late to plan for a cleaner and greener future. With Azure, we have committed to put sustainable technology at the heart of our innovations. So yeah, we'll be planting a tree for every single attendee to this event. So thanks a lot for joining today. And now to the topic. It's my great pleasure to introduce two experts in the field of networking. Akash, with a cloud solution architect for a customer in Singapore. Really hands-on experience on massive networking, as well as Nirmal, who is a global specialist on networking, always updated with the latest and brightest technologies in that field. With that introduction, over to you, Akash, and thanks a lot for presenting.
Thank you, Francois, for a quick introduction, and good morning, good afternoon, good evening from whichever part of the world you are joining. Considering this is the DataFest series event which is going on, so we want to start with a sample as in why networking is related to the data, or I would say the data is proportionally directly dependent upon the network. This is a sample use case which I'm presenting in front of you to set on context. FarmBeat is one of the use case industry solution for smart agriculture. We have it and we provide to our farmers with with features utilizing from the Azure infrastructure, cloud and AI capability, with the intent of basically improvising the crop yield, lower costing, and reducing the overall environment impact. But what is more important, if you would notice, is there are always a networking part in entire game of the things. Whether you are taking the data inputs from the soil sensor or from the drones or from the TV balloon or from the local farm computer, the data is basically going to the edges, and from there it basically leads to the private LTE network. Once it lands to the LTE network, you are setting up a private connectivity back to the Azure, and it's going for Azure for data processing. So what happened when the data is getting processed, something is also going back to the farmer as an output, which is where the things comes into the picture. So what the key context, or the point which I want to mention is, even though the data is getting processed in cloud, even though we are capturing the data from on ground and we are providing the output back to the farmer, there is always a network, and a network without a networking, without a strong network, the things are not going to work. And that's why we want to make this session more around as in how is a highly scalable networking for a data and an AI workload plays a vital role. So moving to the next slide is here in a previous slide, I was talking about the use case, but let's go deep dive as in when it comes to data, modern data lake or a data AI solution, how does it looks like? So this is a sample design, high level design, which I've taken from Microsoft Architecture Center, which basically talks about end-to-end data ingestion, data processing, and data visualization layer. But what is more important is there are end-to-end components, the platform as a services component, there are compute component available, and there are SaaS component. But each and every component is going to talk to each other. We have out-of-box native integration connectors available, but there are enterprises which also wants to have a much more enterprise grade kind of a connectivity like they want each and every traffic to bypass through a traffic inspection. They want to have a control. They want to have a visibility. That's where if you notice this all yellow lines is nothing but a connectivity mode. I can take an example, even though if you're building a data lake on Azure ADLS N2, there are requirements from a corporates which are querying the data using machine learning workspace using private endpoint, which basically means it's going through a virtual network layer. So again, networking comes into the picture. So moving to the next slide, this as in we talked about a use case, we talked about high level design as in how data AI workload looks like from an enterprise organization point of view, from enterprise architecture point of view. When we talk about multi-cloud, we talk about hybrid cloud. How does the entire thing stack together? We may be talking about, let's take an example. The previous slide of data workload is sitting here, but this component is a feeder as well as a consumer for many other business units within the organization. It may be providing data back to the application running in different virtual network. It may be ingesting a data from a different clouds. How are we going to build that connectivity mesh? How are we going to provide low latency, high throughput connectivity, ensuring all the data pipeline, all the data lakes, things works perfectly fine. I'll not go deep dive in this slide. We have a next couple of slides. I will be covering this part, but this is what we intend to cover in these slides in this session today. Now, what are we trying to solve? We are trying to help you build and design and a highly enterprise scale, I would say the landing zone, but considering the load, considering the geographical requirement and considering the variety of requirement, these are important part. If you have a huge data processing requirement, how are you going to address? If you have a different geographies where you are dealing with, how are you going to handle it? How are you going to handle different type of connectivity, point device, site to site, private endpoint, private link? There are plenty of things. There are always confusion, but we are going to make it simple. Most important, we are living in the world of multi-cloud, hybrid cloud. How are you going to build seamless bridge? It's not just about connectivity. There are many more things we need to work upon it. When we deploy architecture in enterprise, the most important part is extensibility. What if the plan A fails? Do we have plan B? Do we have plan C? That's what we will cover. When it comes to deployment, a small organization, we may be able to do it from a UI beta point of view, CLI, PowerShell. But if you have, let's say, a 200 plus subscription, or I would say 500 plus subscription, 6 or 7 geographies you're operating, how are you going to deploy this? Very fast, but recorded standard deployment. There are options available. Offer productivity, predicted toleration change. What if you are under attack from some sort of DDoS or some sort of things? What is the tolerations you can afford to make the changes and make sure the environment is least impacted? Super secured environment, how are we going to cover it? We will be covering that as a zero trust principle we can bring in. And most important, cross cloud and cross tenant access. So these are the few things which we will be covering in next few minutes. Level set, we will be talking a lot about virtual WAN hub. Branched, basically nothing. Branch is referred to the express route, site to site, point to site connectivity. Spoke means the VNet peering, which you must be familiar with, and connection is nothing but a peering connection between hub to VNet and other things. We are not covering a kind of a deep dive networking session. It's not a networking masterclass, but good to if we will be planning to do it in subsequent sessions sometime else, but these are the terminologies we will be using it. Now coming to the core topic, basically, as in why and the planning needs to be a careful planning is required when you deploy a data lake or a data solution of massive networking requirement. Examples like today's organizations deploying Kafka streams, they are deploying Spark clusters, and they are ingesting data from various sources. They are providing feeders to the different organizations as well as partners. In that case, what is the planning we need to consider it? The first learning working with different customers, what we have find is go for a divide and basically rule kind of solutions. You need to divide your environment basis upon a business requirement. A business requirement doesn't mean we use mainly from a data requirement. So what you would notice is we have, in our case, first and foremost, we have divided our environment into multiple hubs: data hub, engineering hub, pipeline hub, other system, application hub, which basically means uh, each and every spoke sitting under these hubs can have their dedicated bandwidth. Why? Because we are using virtual WAN, so we don't need to spend any extra money or effort to build our MPLS connectivity or mesh. We are riding on Microsoft network. That is a flexibility Azure Virtual WAN gives you. Second is we are using Azure Virtual WAN Hub concept, which is managed VHub. So we don't need to do a traditional virtual network hub. So Microsoft is managing a hub for you. And we are using secure hub, which basically means this hub is not just a virtual hub. It is having a baked in firewall premium edition inside it. What is the advantage? I will tell you in subsequent slide. But important part is once we have this hub is basically going to give you a total bandwidth of 50 Gbps. That is basically a cap. And it's not a cap only for virtual hub. Even if you go for a virtual network, traditional hub, that is the cap. Now, what if you have a more requirement beyond 50 Gbps of requirement because your different application has a different customers? This application needs to have a dedicated bandwidth. What is the way we can do it? So what advantage we can give you pattern suggestion is each virtual hub should have their own express route circuit, which basically means when each this application needs to communicate back to data center or back to different cloud, they will go and come back from this route. They will not go through the other route, which is where you will have a dedicated bandwidth. The other advantage, all the spokes, the spoke 1, spoke 2, spoke 3, and spoke 4, they can operate and consume under the limitation of 50 Gbps, which basically means we know clearly what is the bandwidth we have it and how much we can hit, which that's where the planning can come handy and we will not hit an issue because we have planned it very well ahead. The third option advantage is you will have a easily routing management it. Now, if we go back to old days, we used to have virtual network peering done, and each virtual network we used to have route table associated to the subnet. When it comes to the virtual hub, you don't need to do that. In fact, you can control a policy that no users, or I would say the developer operating here, can play with the routing tables or associate. The IT or basically the networking team can do the all routing management at a virtual hub, which basically means your dev basically operates here with the freedom. They don't need to worry and think about anything from a networking side. IT is managing them, that's basically the advantage. So you can have a clear cut control. If example, the production can only talk to production, it can be done by IT, but production cannot talk to staging. It can be done. No need to have developers sitting in production planning or doing anything. So this is coming. This gives ease of management at the same time the compliance control. So this is basically the reason what the pattern what we have found it. Have a dedicated hubs. Each hub should have a secure firewall. If in case you want to have an internet egress, all the hubs sitting here there in spokes, they can go to this firewall, and the firewall can be control all the firewall, not one, two, three, four, whatever firewall you're running. You can have a single policy which basically can work and operated by IT team or basically the NOC team, which basically means if there is a URL or if there is a web category which needs to be allow or disallow, they can simply do it in a one click or one script. That's again an advantage for you to do it. You don't need to manage separately for anything from internet egress. Same goes for IDS, IPS, which the feature of firewall, you can do it. Even advantage for using this topology is if in case, particularly for a BFSI or a government customer, we have a data center here and we have an application running here. This branch to application traffic, they want also to be bypassing through the firewall. Can it be done? Yes, it can be done. You can bypass and you can inspect the branch to spoke traffic using via firewall, and you can do that basically in a networking topology. We call it east-west traffic. You can do that if you have secure up. It is quite easy and it can be controlled and managed from the central IT using the route tables here itself. No need to have any role of the developer at a spoke level. So moving to next slide. So the key consideration, this is what our recommendation. Go for a virtual WAN with a virtual hub. Each hub will give you aggregated throughput of 50 Gbps. If you can see the depiction, each connection, the connection which are basically the yellow dots, can consume any bandwidth. But when you deploy your VNet, you know estimated how much bandwidth it can cap. So you plan your hub accordingly so that it doesn't go beyond 50 Gbps. Centralized DNS control, no hard-coded IP. What you would notice, I'm using Azure Firewall DNS proxy feature, and I will cover this in detail as in how it is helpful, because building a connectivity is not just a solution. How is your workload running on an on-premise? Let's going to communicate to a storage account sitting here without a private IP, like without a hard coding a private IP, simply using the FQDN. So then we have a solution wherein you can deploy Azure Firewall, and that firewall can have a DNS proxy enable, which basically means the request coming from on-premise or different cloud hit to the firewall, and your private DNS zone can basically forward the request to storage account private IP. So best practice is no need to do a hard coding of IP from the environment you are running. Each environment, if you're running it separately, can be isolated from a compliance point of view if you operate in a same separate hub. As I mentioned, routing can be easily planned, and ingress can be intercepted using Azure Firewall sitting under the secure hub. Now moving to the next slide. What if you need more than 50 Gbps? We had a customer who was asking us, I have a requirement and 50 Gbps cannot be sufficient. So what was the scenario? What they were ingesting huge amount of data from these connections. We were giving them dedicated connections, if you notice here. So ingestion is happening, but there is an application running here which needs to access this ADLS or a database or a data lake. And the ingestion is going, this application consume heavily. So the option A, obviously the pattern is you go to the hub, and from the hub you go to another hub, and then you go and access this data, ADLS or a data lake pattern, default pattern. And this default pattern can give you maximum of 50 GB. But if you hit more than 50 GB, there is another option. The other option is this ADLS, you can have an injection of the private endpoint sitting in this VNet. So then you can hit more than 50 Gbps. And similarly, if you have another cluster or application which needs to access this and you need more than 50 GB, then you can inject his private endpoint here. What happened in this case? In this case, the traffic goes through data plane, not the control plane. But on option one, wherein we are going through the data control plane traffic, which will basically give you 50 Gbps. So this is the pattern which you can explore. And in our testing, we have found we have hit more than 80 Gbps kind of a bandwidth if you go for pattern private endpoint. Now, question is, OK, this is fine. We need more than that. even beyond 50 GB or beyond 80 Gbps kind of a speed. How much, what's the pattern? The If you need more than that, the pattern is like a traditional pattern, basically keeping things together. So you have AKS cluster running here in a VNet, and you put the VNet and the private endpoint also sit together. So basically, it will become a clutter of a lot of things in a single VNet. It will be kind of a congested VNet, but we have found that it hit in the range of 100 plus Gbps kind of speed. Point to note, always use accelerated networking interface enable on your interface if you want to go beyond 50 Gbps kind of a throughput in these kind of scenarios. Now, there is also interesting pattern we have come across industries wise. What if you are an organization, let's say, which is providing an services to the consumer? Let's say you are a banking booking app and you are providing a services to the banks. But what you would notice is your VNet is same a CIDR and their VNet is also same CIDR. So if you're familiar with the VNet, you cannot VNet peer in this scenario because you will have a conflict IT CIDR. The another issue is generally for a different organization, you don't prefer doing a VNet peering. So what is the solution? So solution is basically we use private link as a service data provider connection. So you basically publish your service behind a load balancer. You publish your private link. When you do a private link, you will get basically alias and provide this alias to this organization. This alias can be added and they will create a private endpoint. Once he added, it doesn't set up a connectivity. What happened? The moment it add alias, the request goes there. They need to approve or reject. If they approve, then basically they will start connecting it and the connectivity established. Now, how are we connecting in this case? There is no VNet peering. In that case, you are basically riding on Microsoft network, backbone network. So even though you are using same CIDR, even though you don't have VNet peering, you basically riding on Microsoft backbone and all the netting is being done by us. So it won't traverse through internet. You will still see and kind of consume the services without an issue. Now, I may road to zero trust. This is very, very interesting topic and very, very important. And this is critical when you go for basically the cross cloud, multi-cloud kind of connectivity, because L4 level connectivity, VNet peering, express route, all those things are easy. But how are application going to consume things? That is the important part. So what I want to highlight here is this. If you look into this design, let's say you have a organization running in AWS, right? And it needs to access services to Azure. Let's say storage account, or I would say the private AKS cluster running here. This application needs to access this private AKS cluster and we have connectivity, but you know, the private AKS cluster will have a private cluster URL. We are not going to allow any hard coding of things. In fact, private endpoint should give you private IP, but you should not use private IP. You should always use private FQDN of that services. So what we suggest is the pattern one, use obviously the secure hub. The second thing, use Azure Firewall, enable DNS proxy. DNS proxy is a feature which basically route a request coming from the source organization at port 53. You have your private DNS zone. So if you see over there, there are private DNS zone created. You have centralized private DNS zone. Do a VNet linking to the firewall and do the VNet linking to the VNet through which you want to do a resolution. So what will happen? The request starts from here. It lands to the forwarder in the source organization. So let's say Route 53 forwarder. Route 53 tells you need to go to the firewall private IP, right? So it basically uses the connectivity and it lands to the firewall private IP. Firewall private IP sees that you are trying to reach a cluster URL. It basically sees the record. Cluster sees the record and it will basically route the request back to the cluster without having any work to be done from a private IP hard coding. It is all one-time activity because whenever you're creating a cluster or a services, it will ask you, do you want to use existing private DNS zone or you need to use. My suggestion is have a centralized DNS zone and then let the DNS do the magic rather than doing a hard coding of IP. So in this way, seamless DNS resolution happen. You are not doing any hard coding of IP and things works easily fine. And we'll demonstrate it in the coming slides, the same scenario. The second feature, always have a control egress and ingress. So even though you have a secure hub basically also gives you firewall, which basically means anything is sitting on a VNet on production or a staging, always don't allow internet egress from there. In fact, have a policy not allowed egress. And then what do is basically do a outbound egress to the firewall resource ID, which is basically here. So if anybody is running here or here, we'll basically go to 0.0. It will tell you need to go to the firewall and firewall see if the rules are allowed, it will go out. If the rules are not allowed, it will not allow. Now that's the pattern. You should always use it. If somebody try to access it directly, it basically fuel the connection because it will be asymmetric routing. So always any request coming in from internet, HTTP or non-HTTPS will come there. Same goes for outbound. That is the pattern always. And organizations, particularly for BFSI or enterprise organization, government, they'll always look forward for this pattern. And this is for non-HTTP and HTTPS. What if you want to go for a HTTPS traffic or HTTP? Now, the same logic, like the way we have a centralized firewall, you can use it using application gateway. So you can deploy a centralized application gateway and your routing's controlled by a virtual hub. Even though your backend is sitting in different VNet, the things work perfectly fine. You don't need to do anything. In that case, generally, if you would have seen, if you go and deploy application gateway, it has a demand that it should allow internet egress security group to be enabled. In fact, routing, the route table. If we allow here, you are basically breaching the security. So we are suggesting have application gateway in a centralized VNet, and whichever your health backend pool or the path-based routing, do it. Let virtual hub handle the routing. Let developer do the job here and let networking and security handle this part. So segregation of responsibility, secure networking, no need, and DNS is doing things and virtual hub. It's basically end-to-end completely enterprise grade networking work, which will happen if you go this pattern. So we're almost like coming to the demo part, but the conclusion is global coverage. If you're organization of a different global platform, or if you're operating across different environments, different business units, always look forward. This virtual WAN is the solution which can help you to go global on Microsoft backbone. You don't need to invest. Things can be deployed in a minute and you are scalable across globe. That is the advantage. Have a limited entry and exit. What I mean by limited entry and exit is just don't open too many holes, whether it's express route, point to site to site, even a internet egress and ingress point of view. So that's where the previous two slides I was talking about why should we have a firewall as a centralized, why should we have a centralized application gateway? This is where it helps. And virtual hub is controlling and bringing the centralization. Centrally governed. Since Azure Virtual WAN will be giving you a platform at a global level, your virtual hubs are giving you central control of a routing management. Your organization can centrally govern rather than handling it in a isolation or a disparately. Performance priority. This is very, very critical because once you deploy a landing zone or a landing zone, and if you want to make changes, if you come across issue, the changes are troublesome. Why it is troublesome? Because if you are familiar, even the expanding the CIDR, you need to disconnect the peering, although there are solutions now available, but it's a troublesome, which is nothing but a downtime. So careful planning, very well ahead, is very, very critical for your success. Always use accelerated networking for high performance bandwidth. And limited overhead. So always go for the managed virtual hub is the go forward. You can make the changes just by an API call, or using a Terraform or using a Bicep. There are native built-in firewall, no need to have a separate firewall setting somewhere else, right? So it gives you similar feature from a same code base. You can make a changes in a minute rather than going for an hour or a manual job. Even if you have a solutions like SD-WAN in your organization, it gives out-of-box integrations to the solutions like Velo Cloud or a Cisco kind of a solution, and support cross-cloud. Support cross-cloud connectivity is just not the end solution. Always think of how your DNS is going to resolve when the request is coming from a different environment. And that's where we are leveraging Azure DNS, private DNS zone, firewall DNS proxies. These all features comes handy to make it rugged enough, at the same time seamless enough for you to operate. So with that, I will be moving toward a demo part. So we are going to cover 3 demo scenarios here. The first scenario is cross-cloud FQDN based DNS resolution. So from a source environment which is running somewhere else, we will try to access a PaaS component using the FQDN of the PaaS, but that FQDN resolution should go through the connectivity, should resolve to the private IP, and we are not going to use, it should not traverse through internet. The second scenario we will be covering is cross hub vSpeed, the speed. How much speed we can hit it with VNet pairing versus right. And the last and very important scenario is a private link demo. What if you have a same CIDR across 2 different environments and you need to still provide connectivity without a peering? So with that, I will hand it over to my colleague Nirmal. Nirmal, over to you. You can share.
Thank you, Akash. Let me share my screen. Perfect. Hello, everyone. I am Nirmal. Really excited to have you all join this session. So as Akash mentioned, we've really looked at different patterns on how you can build a highly scalable landing zone pattern to support data workloads. So in this demonstration, the first demonstration, I'm going to talk about how we can utilize capabilities within the Azure platform to offer DNS resolution. And also this would give private connectivity to a third-party cloud provider to be able to access Azure resources. So I'll go through the architecture and the topology, what we built. So we have an Azure Firewall here, which is deployed to a spoke VNet. The firewall is configured as a DNS proxy. So it's effectively listening for port 53. So any DNS request that's coming to the firewall would be able to respond. The firewall is also linked to an Azure DNS private zone, which allows us to have integration to private endpoints. So if it's AKS, if it's static web apps on a storage account, if it's a data lake that you would want to access, you could essentially leverage the same pattern and have all of your connections come through a private network such as ExpressRoute and access these services. So that's the firewall, which is deployed to a spoke VNet. And then I have a VNet here, which has a VM. I also have a private endpoint. This endpoint is connected to a storage account, which is hosting a static web app. So we will go see if we can access this web app. This is all gelled together by the virtual WAN hub. So this is the vHub here that we've deployed, which is really connecting all of the VNets. It's also connecting the ExpressRoute connection that's coming in. So we have an ExpressRoute circuit. I also have a network provider. The provider is in the middle between my other cloud provider. So this environment is hosted on another cloud provider. So what we will do in this demo is, as a user, I'm going to get connected to this virtual machine here. And from this VM, I'm going to look for, trying to access the web app. So what happens when I try to access the web app is I've also already configured this environment to do all of the DNS resolution from the Azure Firewall. So the first request would be to go access the firewall. The firewall will then have a look at the available DNS namespaces that's available for the firewall. It'll do a lookup and then return with a private IP address, because the endpoint that I'm trying to access is already exposed through private endpoint. We also have a private DNS zone linked to the firewall. So with that private IP, what I would then do is I would use connectivity here, hit the virtual WAN hub. Through the hub, I will be able to access this endpoint and consume this resource. What I've also done for this particular web app is if I'm outside of this network and I try to access this web app directly, it would also deny all of the requests. So that would give us the confidence and the assurance that this particular resource is not accessible via the internet. So let me go to my third-party cloud provider, and I will get the IP address for me to get connected to this environment. And with that, I will go and access this VM. Let me also zoom in. So I'm connecting through SSH to this VM. So what I will do is I'll do a couple of things before I go in and access this website. The first thing is I really want to know, given this is a private link enabled resource, I want to see if I am able to get the name resolution. So first thing I will do is I'll do an DNS lookup, and I will paste the address of the web page that I want to go access. So part of this, what I would expect to get is that I would get two responses. The first response here is the private link response. And I also get the public response here as well. So this is the public name of the web app. And then, as you could see, the firewall is responding back with the private IP. So this is the private IP that we would then use to get connected to this web app. So if I do the same request and paste the web app URL, what it would do is it would go in and access the web app and then return a response saying hello world. So this proves that we could go and access this resource. Even though I am connecting from a third-party cloud provider, I could go consume this resource. So this is the same pattern. Even if you're connecting from on-premises, you could utilize private endpoints by connecting to Azure, and the resolution will be done through the Azure Firewall. So what we've looked at is the client side of things. So let me also show you some of the configuration settings that we have within the firewall. The reason why I want to show this is Akash made a really important point around zero trust. So we really want to understand and log what's happening around the environment. So we want to log who's doing the DNS queries, where it's coming from. So the benefit of the Azure Firewall is it's tightly integrated to the Azure platform. So any request that gets processed by the firewall is also logged to either a storage account or to log analytics. So we can keep that history, and for any audit purposes, we can find out what's going in the environment. So in terms of the DNS configuration, as I mentioned before, we've turned on DNS capabilities within the firewall. We've also enabled DNS proxy, which means that it's going to listen to incoming DNS requests, and then it will forward these requests based on the request that it's receiving. So that's the config on the firewall. And also what we've done is if I go to my private link DNS zones, so private DNS zones, if I go to the web DNS zone, what you would notice here is that I've got one private A record that's created. Also, if I go to the VNets that are linked, you would see here that it's linked to my hub network, which is where the firewall is hosted. If I go back to the firewall itself, as I mentioned before, if I go to logs, and then if I query for DNS specific log data, what this would give me is it would also show me the events that are being processed by the firewall. So it's really important from a security and compliance point of view for us to be able to log all of these different requests that are coming in from the firewall. So if you look at all the DNS resolution requests are all located in here. So these are coming from my third-party cloud provider, and these requests would allow me to go and log all the traffic that's going through from a DNS perspective, plus also allows me to go monitor traffic that's crossing via the firewalls. If I search for the source IP, I can see this is 150, and this is the specific record that we've gone in and queried. So that's the first demo that I want to show, and then want to move on to the next demo that we have. So the second demo is really around scalability, because as Akash mentioned, there's really different patterns around bandwidth and scalability. So it's really important to have proper planning, because if you don't do proper planning, what happens and what you end up with is a poor use experience where you will hit certain limits, whether it's within the VM, within the vHub. So it's important to really understand what is the requirement that you need for your applications, and then start looking at the designing accordingly. So here what I have done is, again, I have a vWAN hub. I also have deployed 3 VMs in each VNet. So there's 2 VNets here connected with each other. And these VMs are deployed with the E-series queue, so it allows me to go all the way up to 30 Gbps per VM. So what I will do, I'm going to quickly switch screens, and I'm going to log into each of the VMs. So here, if I look at this prompt, I have VM1, I have VM3, and I have VM5. So these VMs are all part of the same VNet. And what I'm going to do is I'm going to configure these VMs to be a responder. So essentially, it's going to listen for a bandwidth requests that are going to come through. So let me go configure that. So these are all going to act as listeners. And then what I will do is on the second tab, what I have is I have another set of 3 VMs. And these VMs I'm going to configure as senders. So essentially VM2, VM4, and VM6, these are all going to be configured as senders, and it will start sending traffic to the endpoint. So I'm going to start them all at the same time, so we would know how much bandwidth we would be able to achieve by sending traffic to the receivers. So let me start. First, I've made sure this is all kicked off. Yep, so that's all working. So this one is kicking off. It's processing packets, and here this is now starting to process traffic as well. So all 3 VMs in parallel is sending 30 Gbps each. So essentially, we are achieving 90 Gbps within this network with the 6 VMs that we have across. So similar to what we are looking at here, what I want to emphasize is that depending on your use case and depending on what you're wanting to achieve, you can scale the platform. So if I want to get 120 Gbps, I can add another set of VMs and I can go achieve that. But really comes down to how you want to plan the environment, whether you want to cross through the firewall, whether you want to cross that traffic through the vWAN hub. Depending on that scenario, you would have specific limitations. So example, the vWAN hub can go all the way up to 50 Gbps, and the firewall can go all the way up to 30 Gbps. The other thing to keep in mind is that different services have different timing around the way how they scale. So example, the vWAN hub would take a bit longer to scale from 2.5 Gbps when it goes all the way to 50 Gbps. Similar to the firewall will also take time to scale from 2.5 Gbps to 30 Gbps. So these are the things to keep in mind based on what kind of requirements you have. Do you want quick burst capacity, or do you need a capacity that you continuously and gradually grow up to a certain threshold that you would want to meet? So that's the bandwidth demonstration. So I'll just stop these connections here. So this gives you a summary as well. So you can see the throughput we've reached 30 Gbps in each of these sessions, totaling up to 90 Gbps. So let me come back to my third demonstration. And this is again a common scenario that we are seeing now. So it wasn't really much of a concern in the past. But as Akash mentioned, a lot of customers who want to integrate with third parties. Here, some of my customers, especially public sector customers, they want to look at how do we consolidate different agencies together. So part of that, you have this challenge around overlapping IP addresses. So in this particular demonstration, I have 2 VNets. So here you can see there's one VNet here, there's the second VNet. both VNets are configured with the exact same IP address space, which means that I cannot go in and peer this, because if I try to peer them, it will give me an error because the address space is overlapping, so would not allow me to peer. So what we've done in this scenario is we've leveraged a capability called a private link service. So we've deployed the private link service here. And then what we've done is we are hosting an application here. So it's a Docker-based application, which is also a web app. And then it's hosted with a load balancer, so it allows you to scale. So it doesn't have to be a single VM. We could have multiple VMs behind the load balancer. And the load balancer is then connected to a private link service. What we've also done at the other end, which is the consumer end, we've created a VM, which is a VM I will be using shortly in the demo. I've also created a private endpoint. So the purpose of the endpoint, as Akash went through the flow, this endpoint is linked to the private link service, and you have to approve the connection. So it's not that you know the resource ID and you can just go in and connect. It's an approval-based connectivity. And then with this approval, what happens is it forms a tunnel and allows us to connect. Even though we have the same IP range, we can go in and connect and consume this web application that's hosted in the VM. So let me show what the environment looks like before I jump onto the client VM. I'll specifically show the two VNets. So here you would see I have two VNets here. So this is the VNet 181 and the VNet 295. So this is where I've hosted all the applications. So if I go to this VNet, you will see it's the same address space as I showed in the diagram. Also going to peering, you can see there's no peerings connected. So this VNet is a standalone VNet on its own. It does not have any kind of integration to any other service. Same goes with the other VNet. If I go to peerings here, you will see it does not have any peerings set up, which means that it's also standalone on its own. We do have quite a few resources here. So I'll deploy the VM. I have a load balancer. I also have my private link service resources hosted here as well. So to demonstrate how this is going to work, what I will do is I'll log into VM 101. So let me switch back to my environment. And here I've actually logged into this VM. So this is VM 101. And if I check the IP address, you will see this is IP from the VNet that I'm part of, so the 172.16.16.4. So what I'm going to do now is I'm going to access a web app that's hosted on the other VNet, but I'm going to leverage the private link capability for this. So how I'm going to access it is I'm going to use curl, and I'm going to access the IP address of the other end. So here the IP address is going to be the private endpoint that gets created locally in my local network. And this would then allow me to go access that web app. So here, it's essentially tunneling that connection through private endpoint, hitting the private link service, and the service is then sending the traffic to the other VNet. So if I access again, it would do the same thing. So it allows me to go and access. So it's a really good scenario that allows different organizations to talk to each other. Also allows, when you are doing any kind of consolidation, allows you to overcome some of these challenges around IP overlaps. So rather than having to do different net conversions, you could easily leverage the private link service functionality, and allows you to net all the connections to the environment rather than having to do a major network rework. So that's all I have in my demos. So I think with that, I will hand over to you, Akash. And we can take some questions.
Hey, thanks, Nirmal. Awesome demos, I think. So team, everybody, like you can see how easy it is. It's quite, it's simple out of box experience. If you want to play around it, have your subscription on Azure, create some virtual hubs, build some spoke networks, play around routing, play around this private link things. It's just out of box features we are giving you. You don't need to do it kind of a quite deep engineering work. And I will again repeat my conclusion, which I did it before moving to the demos, is always have have planning well ahead. If you are hearing the messaging continuously, is like we are saying that plan well ahead. always plan for a limited entry and exit, because this is very, very critical from enterprise security point of view. Virtual WAN, virtual WhatsApp hub is giving you the centralized governance, be it routing part, be it centralized firewall. Performance should be taken consideration from a day one when you go for a design part, not even like execution, because you need to plan how many virtual hub if you want to do it. Traffic for branch going to branch also go through firewall, then you don't have 50 Gbps, you have only 30 Gbps in that case. So you need to see how many virtual hub you need to have in that case. And with that, I will move to the next slide, and we are open for questions. And if any questions you have, Franza, you can share.
Yeah. So maybe we jump for a question before reminding you that next week there is a live sessions on security. So please register if you haven't done so. A very specific topic on how to visualize the threats on your network. Let me go through the question which were asked during the live event. The first question was about V1 and the hub and spoke topology. Can they coexist?
Okay.
Yeah.
Yeah, go ahead, Nirmal, you can answer that.
Okay, yeah. So yes, hub and spoke topologies, a lot of customers today, if they have started the journey 3-4 years ago, we didn't have any virtual WAN functionality. So we see a lot of customers already on the hub spoke topology. So the hub spoke topology and the vWAN topology can coexist. The mechanism we use is if a customer is already using ExpressRoute, the ExpressRoute circuit can be the gelling point between the two patterns. So that would then allow you to have coexistence with the old environment and the new environment, and allows customers to seamlessly migrate in their own pace. Yeah.
Thanks, Nirmal. Another questions about maybe the topology. In banking environment, our regulation says that even east-west traffic as well as spoke to branch traffic should also traverse firewall for packet inspection and logging. Is it a supported pattern, and what is the recommendation?
Yes, so this is a very common question and a request which we have been hearing from, particularly from a BFSI customer, government, and even healthcare customers. Because in those scenarios, even the internal traffic are being logged and inspected. Because if you hear the latest threads of trends of the threats, is the most security vulnerability or the threat comes from inside rather than outside in. So therefore people want to see who is doing what request is coming from there. Somebody has plugged in some malware, is this communicating internally? And yes, in those scenarios, you can use Azure Firewall to do the entire east-west traffic via firewall, even from spoke to the virtual, the branch via firewall. The only catch is it will doing so, you are putting more strain on Azure Firewall, which means you are going through virtual hub from a routing point of view, but the routings are basically pointing every traffic going through firewall, which basically means the firewall which has a limitation of 30 Gbps throughput versus the Azure Virtual Hub, which is having a limitation of 50 Gbps, you will be capped and at 30 Gbps. So plan if in case you have a huge bandwidth requirement for a data flow, and that internally versus internal to the branch, you should plan as how many virtual hubs we need, because those will have been secure virtual hub. And in that case, you can avoid the 30 Gbps part. The good part is that the Azure Firewall is quite scalable, right? So it works, scale out very fast, but it cannot, it goes at max to the 30 Gbps. So that is the only part. General recommendation, avoid passing your branch to spoke traffic via firewall. But if you have a compliance requirement, then definitely it is a solution which is supported.
Okay, thanks a lot, Akash. Nirmal, you did a presentation on cross-cloud FQDN. So there was a question. Your cross-cloud FQDN solutions pattern looks awesome. Can we use it for bi-directional DNS resolution?
Yeah, so the DNS resolution, it is only one way. So right now we don't have the capability to utilize any conditional forwarding within the firewall. So that's a capability that the platform team is working on adding at a future date. So today, if you do want to use any kind of bidirectional forwarding capability, you should either host a domain controller with DNS or look for a container-based approach such as core DNS. So there's different patterns to look at, but not the Azure Firewall.
Thanks a lot. Question on the hard limit. We mentioned 50 Gbps for VNet, 30 Gbps for the firewall. Are these hard limit or can we burst?
Yeah, so with the capacity that's available within the hub, the way how it's designed is, given it's a managed service, it starts with 2.5 Gbps, and then based on the bandwidth demand, what it would do is it would automatically scale out all the way up to 50 Gbps. But the key consideration here is that you should not expect to go from 2.5 to 50 in an instant. So you got to always plan around how long it takes for it to scale out. So typically it takes about 20 to 25 minutes for it to scale to the next threshold, and then it will further scale. So I think the important thing to emphasize, as we mentioned before, is to really understand the nature of the workload and to plan accordingly. So Akash covered the different patterns around it. So if you need burst capability, you should consider a different pattern.
Thank you, Nirmal. And maybe a last question from George. This concept is looking interesting. Can we use the V1 to replace our existing MPLS or backbone connectivity across countries?
Yeah, so that's a common trend that we've been seeing with a lot of customers, and a common question we get asked as well. So depending on what the customer wants to do, in most cases, we work together with an MPLS provider. So it essentially complements the MPLS connectivity. And then utilize vWAN for Azure to Azure connectivity. So you might have some workload hosted in Singapore, and you might want to use Australia as a disaster recovery site. So that allows the two virtual WAN hubs to talk to each other, utilizing our backbone. So think of it as a way to complement the existing MPLS. But if the customer wants to go with SD-WAN solution, in that case, they could look at replacing the MPLS as well. So it comes down to the different requirements they have.
Thank you so much, Nirmal. I think we have covered all the Q&A from the live event. Attendees, thanks a lot for joining today. I would love to hear your feedback. Please let us know what goes well and what we should improve. Please join that survey. Nupo also put the link to the chat, so you can answer either from clicking on the link or scanning the QR code, which appears on your screen right now. Thanks everyone for joining today.
Thank you all.
Thank you all, and good session, and look forward